Okay friends, now let's go to the third condition. Let us see the third condition, and here we will not be deriving any condition, but we will be proving a condition. The condition is like this: three sides of a trapezoidal section of the most economical section are tangential to the semicircle described on the waterline. It means that if there is a trapezoidal section like this, and if O is the mid of the top width, and if you are drawing a semicircle with a depth of flow as radius, if this trapezoidal section is most economical, then these three sides will be tangential to the semicircle. I wish to tell you it once again. Suppose there is a trapezoidal section and O is the midpoint of the top width. If you are drawing a semicircle with a depth of flow as radius, and if the trapezoidal section is most economical, then these three sides will be tangential. So we are going to prove this condition. So first of all, we have drawn a straight line onto the sloping side AB, and we are going to mark this point as F. So OF is a straight line meeting the sloping side AB, and this angle will be 90 degrees. Since it's a straight line, it's a perpendicular to the sloping side AB. So I meant perpendicular. So I'm sorry, I told a straight line. Consider it as a perpendicular. Okay. So we have drawn a perpendicular OF, and the OF is perpendicular to the side A. Now sin theta is equal to OF by OA. Therefore OF is equal to OA sin theta from this triangle. And from triangle AEB, you can write sin theta is equal to AE by EB. Now AD and BC are parallel lines cut by a transversal, so these two angles will be same. AE is equal to D and EB is equal to it's AE by AB. I'm so sorry. It's AE by AB, not EB. AE by AB. I'm so sorry. So AE will be D divided by AB will be root of D square plus N square D square from Pythagoras theorem. Taking D outside, we can write it's D by D in the root of 1 square plus N square. Cancelling D and D, we can write sin theta is equal to 1 by root of 1 plus N square. Now let's mark this as equation 1. Now substituting this result in equation 1, substituting this result in equation 1, we get OF is equal to AO sin theta, that is equal to AO into 1 by root of 1 plus N square. Now what is AO? AO is half the top width. AO is half the top width. So OF is equal to half top width into 1 by root of 1 plus N square. Now what is half top width? Half top width is d into root of n square plus 1. Half top width is d into root of n square plus 1. We had derived this result a couple of minutes earlier. So half top width can be written as d into root of n square plus 1. So OF will be equal to d into root of n square plus 1 into 1 by root of n square plus 1. Therefore OF is equal to d, that is depth of flow. OF is depth of flow.
Over here I have redrawn the figure ABCD. O happens to be the midpoint of top width, and we have dropped a perpendicular towards the sloping side AB. Now we have just now found out that OF equal to D, that is depth of flow. Now if we draw a semicircle with OF as radius, let me try to draw one. It's not like that. I'm sorry. With the OF as radius, the line AB will not cross this circle, and it will not be at a very large distance from the circle, but it will just touch over here. If you are drawing a semicircle with D as radius, the line AB will just touch and pass the circle, because the line AB is at a distance D from O, so it will just touch and pass. That means AB is a tangent to the semicircle drawn with radius as depth of flow. So that is the condition that we have to prove. Similarly, by dropping another perpendicular towards this sloping side CD and another perpendicular towards the base with BC, we can establish this same condition and we can prove. So I wish to repeat it once again. ABCD is our trapezoid. We have marked the midpoint of the top width and we have dropped a perpendicular towards the side slope. And we have just found out that OF is equal to the depth of flow. OF equal to the depth of flow. And if we draw a semicircle with O as center and OF as radius, this line AB will not cross that semicircle. It will not pass like this. And the semicircle will not be at a very high distance from ABC. This will not also be the case. The semicircle will just touch and go, thus making AB tangent to that semicircle. That's what we have to